So, what have you just seen? You've just seen my success in my project to boil water, where I'm using a solar panel, 180 watt, 30 pieces of 2810 diodes and a pot. Test number 1 to test number 6, fail. Test number 7, success. The prototype heating element. 30 pieces of 2810 diodes. Diodes 19 to 30 are connected in separate banana connectors. I use dry pool filter sand, grain size 0.2 0.5 millimeters to protect the diodes from overheating. In test number 1, without sand, the diodes popped like popcorn and broke at 65.5 degrees Celsius, 150 degrees Fahrenheit. In test number 5, using sand for protection, 3 diodes cracked open and broke at 213 degrees Celsius, 415 degrees Fahrenheit. Sand works great to protect diodes from the heat, but the heat transfer through the sand from diodes to pot is really bad. A viewer gave me a tip to use oil instead of sand for excellent heat transfer, but my prototype is full of holes. Another viewer gave me a tip to mix the sand with either silicone oil or glycerin to completely remove the tiny pockets of air that's surrounding every grain of sand. I will do some testing with this in my upcoming sand battery, see what the difference is in heat transfer. Let's move on to the boil. The diodes are preheated to 100 degrees Celsius, 212 degrees Fahrenheit as in previous tests. 250 milliliter, 1 US cup of 12 degrees Celsius, 54 degrees Fahrenheit tap water. In this test I use both an analog and a digital thermometer. In test number 6, the digital thermometer in the lid showed the wrong temperature, but now it is correct. Test number 7 starts at 14:46 to 46 p.m. Okay, 53 minutes have passed, and it's close now, so there will be video from here. Before this test, I replaced 6 banana connectors in the prototype. The reason for this was that the plastic had started to melt in previous tests, creating a short circuit risk against the metal. This prototype has finished its job after this test. Time for version 2.0. The last few degrees until boiling takes forever. This time I let it heat for a while longer before I removed the lid. "56 minutes in, and the diodes have switched between 5.73 and 6.71 amps. The heat difference between the diodes and the top of the sand is significant. If I had had 194 degrees Celsius, 390 degrees Fahrenheit in contact with the pan, this boil would have gone much faster. Heat transfer with sand mixed in all will be very interesting in the sand battery tests. Here we go. Look at those lovely boiling bubbles. The heat dissipates quickly without a lid, so we bring it to a boil again. Follow it in real time, or fast forward 6 minutes to 16:38. Time for some more background music. We take a look at the test number 7 setup while we wait for the second boil. Here you can see both the discoloration and how soft the plastic is from the heat. The diodes are therefore too close to the plastic in the contacts. More space is required. 99 degrees Celsius, 210 degrees Fahrenheit, so close, but still a long way off. Time-lapse on watt meter, 1 minute between still images. The plastic is so soft that even the tension in the cable pulls them aside. The next prototype will have a completely different design, but first I have to solve the heat transfer in the sand. (99.8 degrees Celsius, 211.64 degrees Fahrenheit, and still 1.5 minutes to go. The steam seeps out of the hole where the thermometers go through the lid. Reach 100 degrees Celsius, 212 degrees Fahrenheit for the second time. We let it heat up a little more. Again on the steam escaping from the lid. I noticed that I have to lower the beep sound on the time-lapse camera. I apologize for that. Look at those beautiful boiling bubbles. Okay, success. Time to check if we have any damage. Celsius. Fahrenheit. Time to check out the diodes. Already, everyone seems to have made it through. I measured all the diodes to make sure they all passed the test, and they did. So, 2810 diodes in dry sand can handle an average of 6 amps and 194 degrees Celsius, 381 degrees Fahrenheit for at least 1 hour. Problem with the prototype, actually just that the plastic melted on the banana contacts, which means it doesn't last long. However, the flexibility of looking up the panel's MPPT, or just being able to choose which amps I want, by choosing between 19 to 30 diodes, has worked incredibly well. This will be the last test for this prototype, but it did the job. It will be a new design, with better heat transfer, and the solar panel will have as little wattage as possible. I have a little to think about, but I have a pretty clear picture of the new one in my mind. The sand battery, and a new dual-axis solar tracker, that is powered only by solar panels PV to load are next in line. The pool heating PV to load will also get a new update. Thanks for watching, and remember to like and subscribe to get updates on new videos.